This is the T2600 crimping tool, which is supplied by Ericsson for installation at radio base station sites. The box contains the crimping tool plus a series of dies, and you would select different dies for different items that are to be crimped. We would normally use it to crimp, for example, these cable lugs. These are fitted at the end of cables, and you'd use a small die. You'd use the larger dies, for example, for splicing cables using this C clamp. This particular clamp has got two sizes of radius at either end. The larger one will accept cables from 35 to 50mm cross-sectional area, and the smaller end will accept cables from 25 to 35mm. The numbers for the dies are written on the dies. There is a table on the side of the crimping tool relating the cable size with the die identification letters. The two dies are fitted to the head of the crimping tool. So we release the heads, insert the dies, and close the head. If we were going to splice into the middle of a cable, at this point we would pass the cable through here before we close the head. Now let's splice two cables together. First of all, the cable must be prepared. Strip the insulation, the same length as the clamp, but a couple of extra millimeters just for safety's sake. Remember that this cable may be many meters long and we're crimping in the middle of it. Insert the cable to which we're going to splice into the same clamp, so the two are positioned nicely. The little bit of extra insulation at the end here prevents the cable strands from splaying outwards. This we now put into the crimping tool. Insert the clamp into the crimping tool. Close the tool and position the clamp to one side. We are going to crimp at only one side for the moment. Ericsson recommends it's crimped twice, once to the left and once to the right. The next step is to release the tool. At the moment it's locked, so we adjust the lever here, position this to the yellow dot, and the tool is open. Turn the other lever around and we take up all the slack. So now we can begin the crimp. Begin the crimp by moving the lever downwards, upwards, downwards. Now we've released it after the crimp, and we push the clamp through the tool and position it for the second crimp. Once again we take up the pressure and begin the crimp. So what is it that makes this a good joint? As you can see, it's well crimped. There are no strands of cable sticking out. But if we cut into the joint, we will see. I'm not going to cut this joint, but here's one that was prepared earlier. As you can see, this is just one piece of copper. It's not lots of strands of copper. It's not a clamp just holding them together. It's been compressed to such a degree that it's all a part of the same piece of metal, and that is a perfect joint. If the clamp was too large, or we'd used the wrong size of cables, then it would look more like this. Here we have got the same crimped joint, but you can see all the strands of conductor. Not only can you see the strands, but they still move. And because they're moving, there is not a good electrical contact. There could be arcing or anything. This is a bad joint. Another one of the crimping tools that are used on Ericsson sites is the hydraulic version. This is much more powerful and will accept larger dies. It is the dies that are pressed around the work in order to press them together, and the dies can accommodate cables of 150 square millimeters. There are a range of other dies used for other sizes, and there are much smaller dies also provided in the kit for smaller cables, smaller dies, or even for the smaller cable lugs. The dies are fitted to the tool, but before we continue, the heavy die has got this ridge, which means the die is much wider because it takes a bigger cable. We need to reduce the shoe in the tool in order to accept smaller die, and we do that by adjusting this screw here. Press it in, rotate quarter of a turn anti-clockwise, and it locks in. What this does, it pushes out a ball bearing here which is spring loaded, and so it grips the die and prevents it from falling out of the tool. So we put the two dies into the tool. One in the top and one here in the base. So now we're ready to begin crimping. But before we do this, we have to prepare the cables. Normally, we would splice in a piece of cable to an existing cable, maybe an earth or a ground cable. And we do this by putting this C-sleeve or C-clamp around the cable, and it grips them. Okay? The older crimps were made of copper, but the new ones, of course, are made of tinned copper. It just means there's a slightly different colour. What we have to do is to take away a piece of insulation from around the cable so that we can expose the cable, and we're going to splice to that a new piece of cable, and we prepare the joints like this. Notice how we've left a little piece of insulation on the end of it, and this holds the strands of the cable together. Otherwise they'd all sort of splay out and make a very untidy and also an unacceptable job. But now we've prepared the cables for splicing, let's actually do the crimping. Okay, we've now put the tool around the C-clamp and I position it to one side. It stays in this chart provided by the manufacturers that with this particular size of die and with this particular size of C-sleeve, we should crimp twice. So if we're going to crimp twice, we crimp once to the left and once to the right. So I'll push it outwards and I shall take up some slack. Now what I want to do is to pump the handle, and the hydraulic press will press together the C-clamp until we get a good crimp. It's getting towards the end and the pressure will increase as I pump. But when it gets to the end of it and the pressure has done the job, there will be a mechanical noise and suddenly the pressure will be released and we will feel it noticeably. You hear that click? That means it's been crimped properly. We can now press the handle down, press the little red lever at the bottom of the tool here, and this will release the die. Now that we've crimped once, we move it in through the die to the second position and begin crimping again. Again, take the slack, make sure it's correctly positioned, and begin crimping. You hear that? The second crimp is now finished. Release the pressure, open the tool and take out the finished joint. This is a good crimp. There are no strands sticking out. There is no insulation pushed inside the joint. First of all, we see that there are markings on the actual clamp itself. It's been marked with the size of the die. Secondly, if we take a look inside the joint, let's cut it in half for a moment. And here we see that the copper clamp, the copper conductors have all become a part of the same lump of metal. They're all fused together, and this has formed a perfect electrical joint.